Have you ever been in that situation maybe where an AI makes a really critical decision about you?
Oh, absolutely. Like getting denied for a loan, maybe.
Exactly. Or, a doctor using AI for a diagnosis suggestion. And usually you get some kind of explanation.
Right. They try to tell you why.
We hear so much talk about needing trust and understanding with AI. But what if we've been, asking the wrong questions all along? What if we've misunderstood what explanations are actually for?
That's a really interesting point.
Well, that's exactly what we're diving into today. We're looking at some really groundbreaking research that challenges the whole idea of explainable AI, or XAI. It argues that explanations aren't the end goal. They're not the thing itself. They're actually a means to an end.
A tool, essentially.
Right. And our mission here is to help you unpack this new, much more rigorous way of thinking about AI explanations, moving past fuzzy ideas like trust towards, concrete value, real-world decisions.
You're getting specific. I like it.
Okay, so let's kick this off. What's the fundamental problem this research sees in how we currently handle XAI?
Well, the paper puts it pretty bluntly. They talk about a lack of appetite for rigor in the parts of machine learning that involve people.
A lack of rigor. How so?
Think about other scientific fields, right? You define your terms very carefully. You show why something matters. But in XAI, concepts like understanding or trust, they're often just thrown around.
Left kind of vague.
Exactly. Researchers often don't demonstrate why achieving trust or understanding actually leads to better outcomes in practice. It's a bit of a foundational weakness.
Yeah, and it's surprising when you look at how many XAI methods get validated. It's often based on these internal metrics, isn't it?
Totally. Things like fidelity, like how closely does the explanation match what the model is doing internally?
Or local accuracy. How right is this explanation for this one specific prediction?
Right. But the connection to actual practical impact on the person using it, that often gets missed.
Which, according to this paper, has led to the field showing, and this is their phrase, signs of long-term stagnation.
Yeah, it's a strong critique. They're saying the same issues pointed out years ago are still cropping up because the core problem hasn't been solved.
And maybe even more worrying, these methods are being increasingly deployed in settings where they can mislead.
That's the real danger. They let you make inferences about the AI's decision, but maybe without giving you the right understanding of what it truly captures, or crucially, where it might fail.
Okay, so this is where the paper really flips the script. They say a lot of these problems come from a basic framing error. We've been treating explanations as the end goal in themselves.
Right, like, did we produce an explanation? Check.
Instead, they argue, explanations should be cast as a means to an end. That feels like a huge shift.
It really is. It means an explanation is only valuable, truly valuable, insofar as they lead to better outcomes in a well-defined task.
Better outcomes in a task, okay.
And to make that concrete, they use what's called a decision-theoretic framework. It's a structured way to think about decisions and formalize that value. It brings precision.
Okay, so decision theory, how does that framework actually work? What are the components?
Think of it like a recipe for analyzing a decision. Any use case for an explanation is defined as a decision problem. And this problem has 4 key ingredients.
4 ingredients. Okay, lay them out for us.
First, the action space. This is just all the possible choices you, the decision maker, have. What can you actually do?
Right. The available moves.
Second, the state space, S. These are the possible mutually exclusive states of the world. The ground truth you're trying to figure out, like, is the disease present or not? 0 or 1.
Okay, the reality of this situation.
Third, the utility function. This is basically a score. How much do you value, or how much does it cost you to choose a particular action given a particular state of the world?
So the payoff, essentially, or the penalty.
Exactly. And fourth, the probability distribution. What's the baseline likelihood of each of those states actually occurring?
Got it. And they also talk about a decision task.
Yeah, that's just the decision problem, plus how the information you get, like the AI prediction and the explanation, relates to those true states, how it's all connected.
And putting it all together like this, it acts as a kind of forcing function, doesn't it?
Precisely. It forces you to get specific. Why is this explanation helpful? When does it help? How does it help? No more hand-waving about just understanding.
Let's make this more concrete then. The paper uses some great real-world examples. What stood out to you?
Oh, the examples really bring home. Take medical treatment. A doctor deciding on a biopsy.
Okay.
The state is simple. Disease present, 1, or not present, 0, 0. The action, perform the biopsy, 1, or don't, 0. The utility is where it gets interesting. You might assign a score of 0 if you do the biopsy and find the disease good outcome, but maybe negative 100 if you do the biopsy and there's no disease unnecessary risk and cost. And maybe negative 10 if you don't do the biopsy, but the disease is present, misdiagnosis.
So you quantify the stakes.
Exactly. And the signals are the patient's info, the AI's prediction, and maybe an explanation highlighting key risk factors.
That makes sense.
What else? How about recourse provision? An online lender denies a loan using AI.
A very common scenario now.
Right. Legally, they often need to explain why, but the real point is helping the applicant figure out how to change the outcome, how to get approved next time.
Okay, so the goal is action.
Yeah. So the state might be something like, how far is the applicant's profile from the approval threshold? The action is the specific counterfactual input, like what changes could they make? Increase income by X, reduce debt by Y.
Concrete steps.
The utility could be minimizing the gap between their modified profile and the approval target. And the signals are their features, the denial, and maybe feature importance scores, or even direct suggestions for changes.
Like Figel or Lime scores showing what mattered most.
Exactly. Or even direct counterfactuals. And one more feature selection.
For ML practitioners themselves.
Yep. Imagine you want to build the best model, but you can only use, say, K features because of computational limits or something.
Okay.
The state is the true accuracy you'd get with a given set of features. The action is choosing which subset of K features to use. The utility is maximizing that accuracy or minimizing error.
And the signals.
Feature values, model predictions, and maybe a saliency map or SHE values telling you which features seem most important.
Wow. Okay. Those examples really drive it home. It really crystallizes that this framework sees explanations as tools to help us choose better actions, not just feel like we understand something vaguely.
That's the core shift. It's about improving the decision measurably.
Which leads to a fascinating question the paper explores. Who actually benefits from these explanations? Because it's not everybody, right?
Right. And this is where it gets a bit counterintuitive, especially when you think about ideal scenarios.
Talk about the idealized agents first. The perfectly rational, know-it-all AIs, basically. If they already have all the raw data and the model's prediction, does an explanation help them?
The paper argues, no, it doesn't improve their expected performance.
That feels weird. More information should always be better, shouldn't it?
You'd think so. But the argument is that the explanation in this context is just a function of information. The ideal agent already has the features and the prediction. It's seen as a garbling or a summary of that existing info.
Ah, so if you can perfectly process the full report, the summary doesn't add new facts.
Precisely. It doesn't provide any fundamentally new signal about the true state of the world that wasn't already implicitly contained in the raw data for that perfect agent.
Okay. That makes a weird kind of sense. So what does this mean for us, actual humans who are definitely not idealized agents?
That's where explanations can actually make a difference. Precisely because we're boundedly rational. We have limits.
Right. We can't process everything perfectly.
Exactly. And the paper highlights a few ways explanations can help people like us. First, think about misinformed agents.
Misinformed, meaning they don't have all the data.
Or maybe they have less accurate data or just haven't processed it properly. For them, an explanation like those Echefe or Lime scores showing feature importance can be a shortcut.
A shortcut how?
It makes it less computationally expensive, as the paper says, for a human to arrive at a better understanding of the situation, a better posterior belief about the state, than trying to wade through all the raw features themselves.
Okay, so it helps bridge an information gap efficiently.
Right. Then there are misoptimizing agents.
Misoptimizing. They have the right info, but mess up the decision.
Kind of. They might have access to the true data distribution, but they fail to choose the best action anyway. Maybe because of cognitive biases, time pressure, or just the effort involved.
We've all been there.
Absolutely. Here, explanations can help them assess the model's prediction more effectively, maybe gauge its correctness, and integrate it better into their own thinking. Seeing a reason might help overcome inertia or bias.
Makes sense. But there's catch, right? What about people who start with zero knowledge?
Yeah, the uninformed agents. If someone has no prior context, no understanding of the data or the model, the paper argues explanations generally won't help.
Unless
Unless the explanation itself directly contains information about the state. Like if it explicitly says the model is 80% confident this is correct. Otherwise, the explanation is just rearranging information the person doesn't have context for.
So you need some baseline knowledge for the explanation to hook into.
Exactly. It highlights that human expertise or prior knowledge is still crucial.
Okay, this is all building towards a really important point. If explanations are about improving decisions, how do we actually measure their value? How do we get beyond just asking people, did you like the explanation?
Right. We need rigor. The paper proposes 3 specific quantitative ways to measure the value.
3 ways. Okay, what's the first one?
The theoretic value of explanation, which they call EE, delta E.
Theoretic value, what does that capture?
This is the absolute maximum potential improvement in task performance an explanation could offer, even to an idealized, perfectly rational decision maker. It measures the expected gain and score if that ideal agent gets access to the features compared to only having a general prior belief.
So the theoretical ceiling for how much the underlying information could help.
Exactly. And why this matters to you is it's a crucial sanity check. Before you go building complex XAI systems or running expensive user studies, calculate this. If del E is tiny, then explanations based on those features probably won't help humans much either.
It tells you if there's even potential there.
Right. Like in their home pricing example, they found the theoretical value was a 24.2% improvement in error. That's substantial. It shows there's a real value locked in those features that explanations could unlock.
Okay, that's EER, the theoretical max. What's the second measure?
The potential human-complementary value of explanation, or E-compl.
Human-complementary. So this brings the human into the equation.
Yes. This measures how much value an explanation could provide over and above the information a human already brings to the table, maybe revealed through their own initial predictions or judgments.
Ah, so it's about synergy. Does the explanation add something the human doesn't already know or figure out?
Precisely. It compares an ideal agent using both the human's prediction and the AI's features versus using only the human's prediction. It's another sanity check. Is the explanation likely to genuinely complement human skills or just rehash what they already grasped?
And what did they find for the home pricing example there?
The E-compl was about a 9% improvement in error. Still positive, meaning there is complementary value, but less than the total theoretical value. It suggests humans already capture some, but not all, of the useful info.
Interesting. So there's potential and there's potential complementarity. What's the third final measure?
This is the one that matters most in practice. The behavioral value of explanation. Behavioral.
Behavioral. So this is about actual human performance.
Exactly. This is the observed difference in how well real humans perform a task when they do have the explanation versus when they don't. It's what you'd estimate from a controlled user study the average treatment effect.
The bottom line, empirically.
It is. And crucially, unlike the other two, this value can be negative.
Wait, negative. The explanation could actually make people worse.
Yes. It might confuse them, mislead them, make them overconfident or underconfident inappropriately. This measure captures the real-world impact, warts and all.
Wow. So comparing the actual behavioral value to those theoretical bounds, ETK, AE compl, really helps you interpret whether the explanation is living up to its potential or even causing harm.
That's the idea. It provides context for the observed results.
This whole framework offers such a rigorous lens. But let's think bigger picture. Are there limitations or counterarguments? How does this fit into the wider XAI discussion?
Well, it directly addresses those calls for more rigor we talked about earlier. It pushes back against methods, like some axiomatic approaches, maybe for Shapley values.
Right, things that guarantee properties like faithfulness to the model.
Exactly. This framework says, well, faithfulness is nice, but does it actually lead to better decisions? That's the benchmark here. Faithfulness alone isn't the goal.
And the paper acknowledges other issues too, right? Like getting different explanations for the same prediction, or the risk of explanations being manipulated.
It does, and this framework helps clarify things. If you're promoting explanations that are just functions of features and predictions, you're making an implicit bet about the user you're betting boundedly rational in a way your explanation can help.
Because if they were perfectly rational, those explanations wouldn't add value, as we discussed.
Right, it forces you to think about the user's limitations.
So are there situations where this whole decision-theoretic thing just doesn't fit, where it might not be the right tool?
That's a fair question. I mean, the framework really hinges on being able to define those actions, states, and especially a measurable utility function.
Which might be hard sometimes.
Definitely. Think about really novel, future-based decisions, like investing in some radically disruptive technology where past data offers almost no guidance. There's no reliable probability distribution or utility calculation.
Or maybe deeply personal idiosyncratic decisions.
Exactly. Things where defining a standard utility function feels impossible or just wrong. How do you quantify the utility of choosing one life path over another based on some AI insight? The framework might struggle with that deep subjectivity or radical uncertainty.
So it's powerful, but maybe not universally applicable to every kind of human choice.
That seems fair to say. It excels where tasks and values can be reasonably well defined.
Okay, so wrapping this up, what's the big takeaway for you listening right now? This deep dive really forces a rethink of what AI explanations are all about.
Yeah, the next time you see an AI explanation in the news and a tool you use, maybe in your own work, pause for a second.
Don't just ask, does this make sense or do I trust this?
Instead, ask, what specific decision is this trying to help me make better? Is there a clear task here?
And critically, how can we actually measure if it's leading to a better outcome in that specific task? Is its value demonstrable?
It shifts the focus from feeling to function.
And maybe a final provocative thought to leave you with. If some of our most important human decisions are those messy, future-facing, deeply personal ones that don't fit neatly into this decision framework, what else could the role of AI and its explanations be in those contexts? If it's not just about optimizing a known utility function, could it be about something else?
Like fostering a different kind of understanding, maybe, or sparking creativity. Or helping us navigate ambiguity rather than just resolving it.
Exactly. What if the goal isn't always optimal prediction, but something more, exploratory or even transformative, something to think about?